Hello everybody. Last class we talked about the law of sines and the different cases that could happen, like angle side angle or angle angle side. We also said that side side angle would also use law of sines, but something was tricky about it. We called it the ambiguous case. Today we're going to talk about that in more detail. I'm going to show you an example of it, and we're going to talk about area of triangles, how to find the area of a triangle that's not necessarily a right triangle. So here's a good example of how a side-side angle problem could be ambiguous. And by ambiguous, we mean we don't know whether there's one triangle or two, or none. This would be a side-side angle problem. You know that side's 7, you know that side's 10, you know this angle's 20, but we don't know how long the side is, so I put a dotted line to represent it. And I ask you, if I said, hey, will you build a triangle that has that side, that angle, and some length of this dotted line? You could say, yeah, that's easy. Let's just drag the 7 right over here. If I do that, I can make this triangle. With 10 right here, 7 right here, and 20 degrees. And then you could use these two to make law of sines and 10 and that angle. So that seems easy. But there's another triangle you can make. What if this side was flipped the other way? Now look at this triangle. Now I have a triangle that looks like this. Both of these triangles have this angle down here is 20. This angle is 10, or this side is 10, and this side is 7. We don't know which of these two triangles we're talking about. So we have to solve both of them. Since the ambiguous case only occurs in side-side angle, we're going to use the law of sines to find another angle. Once you get this angle, we're going to split the problem into two scenarios. So you're going to always see triangle 1, triangle 2 in these tables. In the first scenario, we're going to just treat it like you would think. Sine of A over A equals sine of B over B equals sine of C over C. We're going to solve for a missing angle. To get the second scenario, once we find that angle, we're going to subtract it from 180. And then we're going to say, well, can I still have this as a triangle? Am I still under 180 degrees for my three angles? So let's try it. You have an angle of 22, a side of 16.8, and another side of 22.4. So this is a very inaccurate drawing, but it's just a triangle to give me some idea. And notice I went and I made a table with all of my given information, triangle 1, triangle 2. I know I had to use side-side angle, and I know that side-side angle could be ambiguous, so I went ahead and did two columns here. So I see that I have a side and an angle that match up. I'm going to use law of sines and say sine of 22 over 16.8 equals sine of A over 22.42. If we solve for A, we would cross multiply, and we would get 22.42 sine of 22 equals 16.8 sine of A. If we kept solving, I would divide the 16.8 over. And then to cancel out sine, I will do the arc sine or the inverse sine of both sides. So A is going to equal sine inverse of this. Now I'm going to type all of that in my calculator at one time so I don't make mistakes. Second, sine inverse, alpha y equals 1, 22.42, sine of 22, divided by 16.8. Some of these problems I'll work out completely, other ones I'll just tell you the answer. This one ends up being 29.995. So angle A, let's use the right color here. Angle A equals 29.995. So let's go fill that in. Angle A equals 29.995. So now here's what we have to determine, can there be a second triangle? Well, to find this second triangle, if there is one, I'm going to take the angle that I just found subtract it from 180. If you do that, you get 150.005. Now let's stop and ask, can I make a third triangle, or a second triangle? Well, yeah, these two angles added up aren't bigger than 180. In fact, if you add them up and subtract them from 180, you would get 128.005. Now let's look at the second one. If I added up these two angles, would they already be bigger than 180? No, they wouldn't. So let's find the third angle. It should be 7.995. This ambiguous triangle is actually two triangles. One with these angle measurements and one with these angle measurements, which means I have to do law of sines to find side C, but I have to do it twice. One with angle C being 128.005, one with angle C being 7.995. My setup's going to be the same. Sine of 22 over 16.8 equals, I'm going to find the side that matches the first triangle, so sine of 128.005 over side C, which I don't know. If I go to solve this, I will get C equals 16.8 sine 128.005 divided by sine of 22. And if you do that, you're going to get 35.338. Now let's find side C for the second triangle. It's going to be the exact same setup, but instead of using sine 128.005, I'm going to use 7.995. So I say sine 22 over 16.8 equals sine of, what was it? 7.995 over angle C, or side C. Cross multiply again, you get C equals 16.8 sine 7.995, the same thing we got last time with a different angle C, and sine 22. Type that in your calculator, and you'll get side C to be 6.238. So here are my two different triangles. You can always double check and make sure you didn't make a mistake. One thing that has to be true is that the smallest angle and the smallest side have to match up. In the first triangle, 22 is the smallest angle, which means that side B has to be the smallest side. In the second triangle, the smallest angle is angle C, which means that side C had to be the smallest side. It works. Biggest angle was 128 in the first triangle, which means side C had to be the biggest. Biggest angle was 150 in the first triangle, which means side A had to be the biggest. Not every side-side angle problem has two solutions. Let's try another one. Angle B is 96 degrees, side B is 3, side A is 24. Well, I have an angle and a side that match. I can say sine of 96 over 3 equals sine of A over 24. Let's cross multiply and solve for A. If I do that, I'll get 24 sine 96 equals 3 sine A. I'm going to divide the 3 over and do sine inverse. So I get A equals sine inverse of 24 sine 96 over 3. Let's grab a calculator and type that in. Sine inverse of alpha y equals 1. 24 sine 96 divided by 3. And it tells me there's an error. Okay? What you need to know if that happens, there is no such triangle. So if you get an error, one of two things happen. You typed it in wrong, so double check and make sure you type it in right, or no such triangle exists. Now let's talk about why. Well, if you do this problem without the sine inverse, so if I just do 24 sine 96 divided by 3, I get a number that's much, much bigger than 1. Remember, sine has to bounce between -1 and 1. I can't take anything, the sine of any angle is between -1 and 1. So I can't have an inverse sine of almost 8. Doesn't work. Also, use some common sense. Remember, the three angles of a triangle have to add up to be 180. So 96 is going to be bigger than these two angles put together. 96 is the biggest angle in this triangle. Because 96, angle B is the biggest, it means side B has to be the biggest. Well, you can see side B is clearly not the biggest side here. Because of that, this triangle won't work. This is an example of an ambiguous triangle that has no solutions. Let's try this triangle. Side A is 7, side B is 9, angle B is 49. So let's fill in what we know. Angle B is 49, side B is 9, side A is 7. So I'm going to match these two up, angle and side. So sine of 49 over 9, sine of A over 7. If I cross multiply, I would have 7 sine 49 equals 9 sine A. I want to get rid of the 9, so I'll divide. And I want to get rid of the sine, so I'll do sine inverse. And then if you type all that in the calculator, which I did a second ago, you're going to get A equals 35.944. So I'm going to come up here, and I'm going to say that angle A equals 35.944. Now we need to see, because it's side-side angle, is there a second triangle? So is there a second triangle? The way we find out is we take the angle we just found and subtract it from 180. And if you do that, you get 144.056. Now let's look at the first triangle. Do these two angles already add up to make more than 180? No, so I can do 180 minus these two and find that this angle is 95.056. Let's look at the second triangle. Do these two angles add up to make more than 180? Yes, they already do. Because these two angles are already bigger than 180, I can't have a third angle. It's already too big. So I know this ambiguous case triangle is only one triangle. I don't have to finish doing the second triangle. The only thing we still have left to find is side C. So I'm going to do the same thing I did earlier. Sine of 49 over 9 equals sine of 95.056 over side C. If I cross multiply, I would C sine 49 equals 9 sine 95.056. Then if I want to get the C by itself, I'll just divide the sine 49 over. Type that all in your calculator, and you will get C equals 11.879. I don't have to find the other side C, because this triangle doesn't have two possibilities, it only has one. So remember, when you see a side-side angle problem, it might be two triangles, it might be one triangle, and it might be no triangles. The no triangles is the easiest to figure out, because when you try to find one of the angles, your calculator will tell you error, because you're trying to take the sine inverse of a number bigger than 1. If it's only one triangle, you'll find an angle, and you'll find the corresponding other angle. But these two angles added together will be bigger than 180. Since that can't happen, there only can be one triangle. The second part of this lecture is about area. How do you find area of a triangle? Well, this is a problem you would have had in geometry. The area formula for a triangle that you're used to seeing is 1/2 base times height. But the thing you have to remember here is that base and height are perpendicular to each other. In other words, base and height meet at a right angle. So I could say for this triangle, it's 6 and 12, which would be 6 times 12 is 72. Half of that would be 36. So that's not a hard problem. But what makes that problem easy? Well, it's a right triangle. What if I want to do a triangle like this? This one doesn't have any right angles in it. Because of that, I need different formulas. So the first formula for a triangle, area of a triangle, is this. If you know two sides and an angle between them, you can use 1/2 AB, which are two sides, sine C. Sine C is the angle in between them. Let's back up to this problem. Let's try to use that formula here. Area equals 1/2. The two sides are 6 and 12. And the angle in between them. It's a 90-degree angle. If you type all of that in your calculator, you say alpha y equals 1. 1/2 times 6 times 12 times sine 90. Oh, look, it's 36. How is that possible? Because if you type in sine 90, sine of a 90-degree angle is just 1. That's not important for a right triangle, but for a triangle like this, it's really important. Why is this one so much harder? There's no right angle in it. But I can still use this formula. It doesn't matter what you call A, B, and C, as long as it's two sides and the angle in between them. So if I type that in my calculator, I'm going to use 0.5 for 1/2, which is faster. 12, 10, and sine 55. 49.149. Is that right? Yeah, 49.149. I give you units in the problem, you have to give me units back. Area is always whatever squared, so square kilometers. So that's one formula we can use. What if I don't know any angles? I just know the three sides. Then I can use something called Heron's formula. To do that, I'm going to calculate S. S is just the three sides added together divided by 2. Then I'm going to take that and I'm going to plug it back into this formula. The square root of S times S minus A times S minus B times S minus C. Now I don't need any angles. I can just use all three sides. So you have two formulas to find area. It just depends on what information you're given. This triangle, I know two sides and an angle in between them. Because I know two sides and an angle in between, I'm going to use this formula. Which is 1/2, 13, 23, sine 98. And if you type all that in your calculator, you will get 148.045. No units were given, so you don't have to give me any units back. Simple problem if you have the right formula. The area of this one is a little bit tougher. There's no angle, so I have to use this formula. Heron's formula. S, S minus A, S minus B, S minus C. Where S is A plus B plus C divided by 2. Well, that's the formula. Let's figure out what S is in this problem. What's the three sides added together divided by 2, which is 20.5. Now that I know that, my area is the square root of S, S minus A, so one of the sides, S minus B, another one of the sides, S minus C, third side. It's a longer formula, but it's still something you can easily type in your calculator. You'll get 80.597. I gave you units, so you have to give me units back, cubic centimeters. So to find the area, depends on what information you're given. Remember, you want two sides and the angle in between them, or all three sides. If you're given different information, like if you're given side-side angle, or angle side angle, you might have to do a little bit more work. Use the law of sines and law of cosines to solve what you need to find.